Okay, let's talk and look at events and then how it kind of works. You can see behind me right now, I've got this nice contingency table with a bunch of data on it, and it may not make much sense. But we're going to go through and look at how we can do a bunch of different probabilities. But just take a look and you see you've got Econ, information systems, marketing, and then whether they're freshman, sophomore, junior, or senior. And so the number of freshmen that are also Econ is 3. But the total number of freshmen for these 3 majors is 15. And so we're going to look at that as we get going, but let's go through some different principles and then we'll look at it at the end. So again, this is not meant to be where we go through the how-to, even though I'm going to a little bit at the end. But let's talk about complement, union, intersection, and mutually exclusive. Now each one of these are extremely important for what we want to do in the future, that being chapters 5, 6, 7, and on. The complement is basically everything that's not that. And so when I talk about that and look at our data up here on the whiteboard, you can see that I've got 15 freshmen and I've got a total of 73 total students. And so looking at the total number of students, if I wanted to know the complement of freshmen, it would be the sophomores, juniors, and seniors, not including the freshmen. So event A, then, as you can see in that, think of that as the freshmen, where everything else is the sophomore, juniors, and seniors. And what we really care about is the complement of A, or the complement of freshmen, which would be, again, sophomores, juniors, and seniors. If we're talking about a union, it's where the two, we're looking at 2 different possibilities, and we want to know both. And so in this case, think of the word or. And so let's look at the whiteboard again, and we see that we've got economics, finance, or I'm sorry, freshman here. And what I want to know is the probability of being an econ major or a freshman. And that's would include both. Let's take a look at how about freshmen or sophomores. So the probability of being a freshman or a sophomore, so I'm using that word or, would be 15 plus 12, add those 2 together, and then divide by your sample size, which is 73. So that's your union when you look at both, and you want to include everything that's part of those 2 parameters. In this case, as you can see on here, it's either A or B, or in our example, it could be freshmen or sophomores. Intersection then becomes the word and. Okay, and is the word that we really care about. And let's go to the whiteboard again. And we see that if we talk about freshmen and econ majors, now we're saying it has to be both criteria. The word or would be the 15 and the 24, and actually subtract out, which we're going to talk about here in a second. But it would be these 3 values and these 3 values, where the word and only refers to that particular part. So the word or would be anything that is a freshman or an econ major. The word and then has to be both. So one or the other is the word or union. The fact that it has to be both is the intersection or the word and. So when we're adding these together, now here's what I was referring to. If I've got 15 freshmen, I've got 24 econ majors, so I'm trying to add these up. Realize what I did there. I added this 3 twice. So you have to subtract out that 3. So that gives us 24 plus 15 is actually 39, minus the 3 gives us 36 over 73. And I've got terrible handwriting today. 36 over 73, and then that's what the probability would be for being an econ or a freshman. Subtract out what's common between them because you counted it twice. You added 8 plus 4 plus 3 to get the 15, and then you did 13 plus 7 plus 1 plus 3 to get that 24. So that's why you subtract out 1. So that's the addition rule. Now, with that, What about if I wanted to do freshmen or sophomores? There's nothing common between them, so all I have to do in that case is add the 15 plus the 12. And that's what you can see here when you talk about mutually exclusive. Freshmen and sophomores are mutually exclusive. So when you add those two together, you do not need to subtract out anything that's common between them because there is nothing common between the two of them. Okay, now one of the final ones here is looking at conditional probability. And conditional probability to me is the word given. And so think about the word given. If I was to look at, let's look at information systems majors and say, given that they're an information systems major, what is the probability of them being a sophomore? So, how many of them are sophomores and information systems majors? So, a way to think about it is get rid of everything else, and the only thing you care about is this 30 right here. Those are the individuals you care about. Forget about the marketing majors, forget about the econ. Just given that they're an information systems major, what is the probability of them being a sophomore would be 6 out of the 30. That's a conditional probability, which, oh, that's hard math on me. That's 1 out of 5, right? Does that sound right? And that would then be 0.20. So conditional probability changes your denominator to just 30 instead of out of 73, and then only looks at what's in that row, basically, when coming up with your probability. When you multiply different things together, you're looking at something happening once, and then given that that happened, what would happen again? So let me use an example here, and how about if we were to talk about sales? Up. And we know that the probability of a sale being successful is 30%. So the probability of being successful twice in a row, think about that. So if the probability of being successful just once, one event is 30%, what's the probability of being successful on 2 sales calls in a row? It would be 0.3 times 0.3, which equals 9%. So when you have successive trials of something, you have to multiply them together. Where this really becomes fun is when you start thinking of the probability of getting blackjack and things like that, but let's not get into gambling in this example here. Okay, let's take a look at this contingency table, and it's the same one that I had on the whiteboard. And if we're talking about different things, we want to look at the probability of, let's go with my little pen here again. Do I have it is red, there we go. And I want to know the probability of being econ and a freshman. Just realize I'm talking about that there. Now that's if I want to be econ and a freshman. If I wanted to be econ or a freshman, I would take this 24 plus this 15 and subtract out this 3 here because I added it twice. If I wanted the probability of being a junior or a senior, then that's what you have here, and I'd add those two together, divide by 73. Finally, what about, let's make it a little bit complicated here, how about the probability of being an econ major and the complement of a freshman? So an econ major, let's write this, I'm going to do this one up on the whiteboard. How does that sound? So the probability of being an econ major and the complement of a freshman. Well, what What we're saying is it's got to be an econ major, but not a freshman. So that would be 1, 7, and 3. Add those 3 up, and that would give you your answer down here. So when you're thinking of probabilities, a lot of times it's always important to look at the possible outcomes as well as expected outcomes. And so you can look at it in terms of that. Let's try, how about the probability of being an econ major given that they're a senior? What would that be? That would be, well, number of seniors is 24, and you have 13 that are econ majors. Same thing down here. What if we did the probability of being a senior given that they're an econ major? Let's do a different one, because we got the same 24 here. Let's take a look at a contingency table example here, looking at conditional probabilities. And in this case, let's look at our information systems majors again and say that we want to know the probability of somebody being an information systems major given that they're a senior. So the senior part is 24. So that's all we care about. It's like we only care about this column right here. And then how many of them are information systems majors? 6. So your probability then is 6 out of 24. Let's look at the kind of the same thing here. What about the probability of being a senior given that you are an information systems major? Well, now it's different, because now you're not looking at 24, you're looking at 30. And 30 because now you're saying given that you're an information systems major, what's the probability of being a senior? Well, there's 30 information systems majors, and there's still 6 that are senior and information systems. So the same stuff, we just changed the possible outcomes in this case. So you should be able to look at something like this and know a probability, just in general, the probability of being a freshman, 15 out of 73. The probability of being a freshman or a sophomore, be 15 and 12. Oops, just realized that should be a 13. Sorry about that. The probability of being a freshman and an econ major should be 3 out of 73. The probability of being a freshman, given that you're an econ major, is then 3 out of 24. So you want to know marginal probability, union probability, joint probability or intersection, conditional probability, and then also the multiplicative rules and addition rules that go along with that. So again, this is nothing but exposure, getting you ready to learn more. The how-to stuff, use our homework manager, the solutions and the guided examples that go along with them to really understand how to do this stuff. But hopefully this gives you an overall of what you're doing.